Optimization example. We have a cylindrical can, which is to be made to hold 1 liter of oil. Our goal is to find a dimension that minimizes the cost of the metal. Well, what do we have here? We have a cylindrical can, and it's built from a metal, all right? So if you think about this cylindrical can, it means that, well, it was made from a piece of metal, all right? So you have a piece of metal, and here you have the following scenario. Suppose this is your piece of metal here, and this is your metal. So you're trying to minimize the cost of the metal. What's that supposed to mean? It means that you have this piece of metal and it has some area. You're trying to minimize the area of this metal. The goal is to minimize the area of this metallic surface, and the surface area A is equal to 2 pi r squared plus 2 pi r times h. Well, what is r? So remember that if you just fold this into a cylindrical can, it has circular base with some radius, and it has a height. This is your radius, and this is the height. Our goal is to minimize this function. Well, this function has 2 variables. This function has 2 variables. We need to get rid of one of these variables. We need to write this in one variable. So you can take the derivative and find the critical value and so on. So what else do we have here? What is the other piece of information that is here? It says, hey, it can hold 1 liter of oil. What's the meaning of that? Well, it means that the volume is 1. So let's write this down here. From this part of the question, the volume is, for example, 1 liter, you can convert that into cubic centimeter. And the definition of the volume is pi r squared h for a cylinder. So pi r squared h is 1,000 cubic centimeter. Very good. So what's the meaning of that? It means that, for example, you can write h in terms of r or r in terms of h, whichever is easier to work with. I'm going to isolate h on one side. I'm going to divide both sides by pi r squared. So I get 1,000 divided by pi r squared, and I'm going to substitute that here into this equation. I'm going to get rid of my h. So my a becomes 2 pi r squared plus 2 pi r h, which is 1,000 divided by pi r squared. Very good. So as you can see, you have a function in R. You can simplify this function. AR is 2 pi r squared plus 2 pi. You can get rid of pi and pi. You can get rid of one of these r's, and you can multiply 2 and 1,000. You have 2,000 divided by r. Well, let's take the derivative because we want to find the critical values. A prime is equal to 4 pi r plus negative 2,000 divided by r squared. Very good. So you can set this equal to 0 to find the critical values. This is our goal. Just move this a little bit up. Set a prime of r equal to 0 to find the critical value. Very good. So 4 pi r minus 2000 divided by r squared is equal to 0. So let us take the common denominator between these two. You have r squared, 4 pi r cubed minus 2000 equal to 0. So you can set the numerator equal to 0, and you have 4 pi r cubed equals to 2000. 4 pi r cubed is equal to 500. Or r is equal to the third root of 500 divided by pi. Very good. This is the radius that we have. Now you can plug in radius into the formula to find your h, all right? My h is going to be 1000 divided by pi times, well, here you have 500 over pi. Here you have a third to the second power, which is 2 thirds. I can simplify this more. H becomes